G'day team, welcome back to yet again another video on calculus. However, today we're starting a new playlist and we're actually going to look at some of the applications of calculus. And now, if you haven't watched the playlist beforehand, differential calculus, then probably go watch that first because a lot of those skills are going to transfer over to what we're going to be doing throughout these next few videos. So one of the things we do with calculus, and the essence of calculus really, is finding the gradient of a tangent to a curve at a specific point. But we want to sometimes take that a bit further and actually find the equation of this tangent. All right, so tangents are linear functions. We know that they're straight lines touching the curve. That means they have the equation either y equals mx plus c or ax plus by equals c. Now this is gradient intercept form, a nice easy form to use, and this is general form. But you got to be able to transfer between the two of them because sometimes in conjecture problems or in exams, they will throw either at you and you've got to be able to tackle both. So if we're told another point on the tangent as well as the point of contact, then m is the gradient required at the required x value, so we can just find the gradient between 2 points. C can be found by substituting the other point, the other known point, into y equals m. We know that value from the gradient, x plus c, to find that c value. But if we're only told the point of contact, then we can use a little formula here. So my y, so my tangent y is equal to f dash of a, which is my derivative at a, times x take a, which is almost like a horizontal translation, plus f of a, which is my y value at a. So a is the specific point x that the tangent touches my curve at, okay? So we can actually do this on our calculator. Now these instructions are for a Casio CG50, all right? So you can have a look at these, have a go trying to work it out for yourself. We're not going to go through it today, but you can definitely check for these equations on your calculator. Just ensure your derivative is turned on in your shift setup. So moving on, let's have a look at a bit of an example. So I've got two examples here. So f of x equals 3x squared plus x plus 3 at 217, and f of x equals sine of 2x at x equals pi on 4. So let's have a look at the first one. Now, for all of these questions, we need to find the derivative. So let's start by doing that. So the derivative in f dash of, in a of f of x, so f dash of x is 6x plus 1. Now, I like to identify the a value. So that's the x value we're looking at. So that's a, and we're actually told f of a already there, which is really nice. If I wasn't told this 17, I'd substitute 2 into this equation and to find it does in fact give me 17. Now I also need to find my derivative at a, so f dash of 2, which is 6 times 2 plus 1, which equals 13. So now that I've got all of that information, I could put it into my formula. So my tangent formula, y equals f dash of a, which is 13, x minus a, which is 2, so we can put that in there as well, plus f of a, which is 17. Now, that's not quite the form we wanted it. We want it in slope intercept form at this stage. So let's expand out that bracket, 13x, take 26 plus 17, and then we just tidy up the numbers. So 13x, take away 9. Now, we could then convert that into general form pretty easily, but this is the way the calculator will also give it out for you. All right, let's have a look at b here now. So my function f of x is sine of 2x. So just like before, let's find the derivative. So f dash of x. Now we know sine goes to cos, a positive cos, and we find the derivative of the inside, which is 2. So I've got 2 cos, and I rewrite the inside 2x. So looking at my point here, this is my a value. Now I don't have f of a, so let's find f of pi on 4. Now that is sine of 2 times pi on 4, which ends up being pi over 2. Now, sine of pi over 2 is just 1. All right. Let's now have a look at the derivative at that point. So f dash of pi on 4, which is 2 times the cosine of 2 times pi on 4. Now, if sine of pi on 2 is 1, we know that cos of pi on 2 is 0. Now, I'll just come over here. I've got 0, x take pi on 4 plus 1. So therefore, y equals 1, which is a horizontal tangent, which makes sense given that my derivative at that point was equal to 0. All right. Hopefully these examples are a bit of a help, and I'll see you ready for the next video. Thanks for watching.